All right, fun on a Friday afternoon with Mr. DeMeo as everyone else is leaving Amity. I'm making math videos. All right, the second way to look at the tangent line problem is to consider what happens as Q moves closer and closer to P, and we let a third variable represent the difference between X and A. So you know that as Q and P start to approach each other, or more specifically Q starts to approach P, the value of X starts to get closer and closer and closer to A. And we use a third variable H as the representation of the difference between X and A. So we have H being X minus A, X being the larger of the two values. You can then also think of solving this thing, and I have some of this done out over here. Whoa, come back. You can think of solving this for the value of X. So if I solve for X, I would add A to both sides, H plus A, or A plus H. So the value of X is really looked at as the value of A plus H. Our big thing is finding out what happens to, what happens at A when X gets infinitely close to A. Which also means that if we're representing this distance by a value of H, what's happening as H approaches 0. So if we go back to the first definition that we had, definition 1, and just swap some things out and change the limit, we get essentially the same problem with different letters and different values that we're going to deal with. So you'll notice that instead of X approaching A, since X minus A is the same as H, we let H approach 0. Instead of having an f of X as our value in the numerator, since X is the same as A plus H, we have f of A plus H. We're still going to do minus f of A. We're still going to do divided by a value. But again, instead of having X minus A in the denominator, X minus A is the same as H. So we're going to go with H. And this is considered equation 2 in your book. It is the H goes to 0 equation for the tangent line problems. We're going to go about doing them the same way. We're going to set up a limit. We're going to try to solve for a specific value, try to get a singular limit, numerical value that represents the slope, but we're going to just do it in terms of these letters. So I have a problem that I'm going to do with you to take you through that particular set of steps. We'll call this example number 3. So let's attempt to find the slope of the tangent line to the curve 2x squared plus 4 at x equals 1. Since the limit formula that we're going to look at, h going to 0, of f of a plus h minus f of a over h. Since we still have an f of a value in here, and our x value, again, we know is at the point a comma f of a, we're going to need to find f of 1. So f of 1 is 1 times 2 plus 4 is 6. So we're dealing with the ordered pair 1 comma 6. And now we can go ahead and throw that in here. We're going to take the limit as h goes to 0 of f of a plus h. So I'm going to substitute the 1 in for a. So this is really a 1 plus h minus f of a, which we said was 6, all over h. And now we're just going to evaluate the function f of x at the value of 1 plus h. So this is going to be the limit as h approaches 0. And I'm going to put a 1 plus h in wherever I see an x. 2 times 1 plus h squared plus 4 minus the 6 that's up there, all over h. And now we've gotten it to the point where we're doing a limit problem in terms of a single variable. There's only h's. So the goal is going to be to simplify the numerator and hopefully be left with something where we can factor an h out to get that h out of the denominator. Because with that h in the denominator as h goes to 0, we're going to have a discontinuity issue at 0. So we need to get rid of it. So let's work the top. and I can distribute my 2, and I get 2 plus 4 is 6, minus 6. So those all cancel out. 2 times 2h is 4h, and then 2h squared all over h. And you can see I have a factor of h that I can pull out of the numerator to cancel with the denominator. That's h times 4 plus 2h over h. And now I'm only considering the limit as h goes to 0 of 4 plus 2h. And that's an easy limit to figure out. That's going to equal 4. Again, if I wanted to take it to the next step and write the equation of the tangent line, I have established my point A comma f of A. I have the slope now. I can go to point-slope form and write you the equation of that tangent line. All right, so that's definition 2. The second set of examples, example number 3, for taking you through h going to 0 instead of x going to a. All right, hopefully that clears things up. I'm going to do another example and then talk about a little physics-y stuff in the last set of videos.